Hey everybody, my name's Tyler Fedrizzi, and today I'm going to talk to you about the Swarm Simulation Platform. So really quickly, what is a Swarm Simulation Platform? It's an integrated full-feature development tool that you can use to simulate, test, and deploy single or multiple agent autonomous robotic systems. We have a number of benefits, such as a really simple, easy-to-use Python-based interface, photorealistic environments in the latest Unreal Engine, and we have a really easily extensible and flexible framework for developing and testing solutions. Now we use Docker for everything, so it's really easy to take the simulation, move it around. It could be a personal cloud, it could be AWS, Azure, could be just on your local computer. There's a number of different options, and we really thought about security from the start with this platform. So really, at the end of the day, it's an automated testing. It's an automated testing platform, and we have a number of different exciting features that we're working on, such as a marketplace where you can go and you can build and sell, or you can buy algorithms for your system, as well as we have a number of different virtual environments, and we can build custom environments as well. Now, the system says the name of the system is Swarm, so you might think multi-agent systems, and that's exactly what we provide. Each agent is its own collection of processes and independent systems, so you're able to modify and make a heterogeneous swarm really, really simply and easily. So let's take a look at actually how you'd interface with the platform. So everything exists through this main simulation settings file, and if you're interested, we have a number of different sets of documentation that's available publicly that you can look and kind of see what you need to do. Now, everything's kind of broken down into sections. Here we're going to run the navigation scenario, which just says, hey, give each agent a goal to go to. We have different settings for your environment, different data that you can collect. You can collect images as well. We're working on other things like LiDAR data, everything that you can use for your machine learning applications. And then we have all a different gambit of sensors, such as LiDAR, GPS, cameras, number of different features there. You can control the PID gains for your position controller, so if you want a smoother ride for your camera, etc. And then what's really unique about the system is that everything is broken down into these software modules. So you'll see I have mapping, high-level path planning, low-level path planning. So it's sort of a natural system architecture. Each one of these is its own independent little Python module that runs completely independently inside the system, and there's a number of different options. Here you'll see there's an occupancy map. We're going to run a custom A-star algorithm, and we're going to use a min-snap trajectory planner to generate a feasible dynamic trajectory that the system will be able to operate on. And you'll see also that was one agent, but I have two, and I can copy over the parameters. I could change what cameras I want to use. I could change any of those features. So each system is independent. Now the A-star algorithm itself, this is a pretty basic A-star algorithm, but like every algorithm that you write in the system, you just inherit from our base class which we provide. You have to write a single run function that takes some keyword arguments, and then other than that, everything else is up to you. So enough talking about this. Let's actually watch the system work in real time. So it gives me a number of options right here. I just say what map I want to go to, which IP address, and which simulation file I want to run. I don't want to create a new one. And you could view a 2D map if you wanted to. However, I won't do that for sake of brevity. So it's going to come back. It's going to actually go and validate your code for you to make sure that it's going to run, and then it's going to load the environment. So once you're ready, you type in that IP address to a browser. Browser comes up, and now you can actually see that this is an interactive, fully featured simulation that you can actually interact with. You can actually use different cameras. You can look at different sensors. And so here, right, you see the agents. They're both operating independently. They're both going in their own directions. And this was an A-star route that was created by the algorithm, and then we used a min-snap trajectory planner to make it, really try to make it as smooth as possible and make that happen, right? So this will take about 30 seconds to a minute, right? But you can see, kind of based off that, right? We have this whole virtual world. It's really easy to interact with. The other agent is over there. It looks like it finished. And you can control the number of cameras that you want to have. So there's a number of different action cameras, right? And at the whole time that this is happening, on board, you're also recording your video as well. So that's really, really nice, a really nice and easy to use feature. This is getting towards the end, so it's trying to achieve its goal. Yep, so now you're finished, right? Simulation will end. And then if we go back here, it'll say, hey, do you want to download your data? you can say sure, right? It's probably going to be a lot of data. That's, it was basically a minute worth of video on 2 different cameras, right? But you download your data, and I'll show you just a quick example of what that data looks like. But see, it's really easy. You can iterate really, really fast. We have a whole submission history and submission list, so you can look at what parameters did I submit three times ago, which ones were better, all of that. And it makes it really simple and really easy to use. So you can see here, right, I have a number of different logs for each of the modules that I have. And really quick, right, what does that look like? This is our low-level path planner, so this is the trajectory. This generates that min snap trajectory, and so you can kind of see it gives controller terms, it gives the command of the position that was completed. It gives a number of different options that you have. So it's a pretty robust logging system. And then also, when we look at the actual videos that are provided, you can go here, look at that. You see each video is indexed by camera, and then if you look at look here, oh, okay, this is the actual video of the agent being recorded in real time. So with all that said, if you're interested, please feel free to reach out and contact either myself or Alex. You can visit our website at www.swarmsim.io, which is our sort of main web platform. It's also how you spin up our cloud servers as well. Thank you.